Welcome to the notes on 12.2, Circles and Chords. We're going to learn three properties, and we'll show you how to use those to solve problems involving those properties. So first one, all right, is if we have two chords that are congruent, well, then their corresponding arcs by the same name. So segment AB, well, then arc AB is going to be congruent to arc CD. Those are going to be congruent to each other. All right, and it goes the other way. If we have arcs that are congruent, well, then their corresponding chords will be congruent to each other. So let's take a look now how we're going to use that to solve problems. We look at this one. We've got congruent chords. Well, that means that this arc is going to be congruent to this arc, which means that's 106. So how are we going to find x? Well, we know that the whole circle adds up to 360. So we're going to add up all of this and then subtract it from 360. So let's do that. We're going to take 106. All right, 106 plus 106 plus 33. All right, and then we're going to subtract that from 360. So we're going to take that number and we're going to subtract it from 360. When we do that, we should get 115. So that's what this distance is right here. So we're going to take 360 minus all of this right here. All right, number two, let's find CE. Okay, so again, I've got congruent chords. Well, that means that all of these arcs are the same. So that's x. That means this is x. This is x. So how am I going to find what CE equals, which is this one right here? Well, I'm going to take 360, and I'm going to subtract the 108. When I do that, I'm going to get 252. 252 is this whole distance right here. But I know that each of those needs to be the same since they're all the same arcs. All right, so I'm going to divide that by 3. When I divide it by 3, I'm going to get 84 for each arc. So there's my answer, 84. That would be the answer for CE. I think I want me to write it right there. My formatting got a little off. So that's the first property. Next one, pretty simple. If you have a radius, it's going to be perpendicular to a chord. All right, it's going to make a right angle. And with right angles, we're going to probably end up going to do a lot of Pythagorean theorem. And it goes the other way. Not only is it perpendicular, it's a perpendicular bisector of the chord. Okay, so that's going to be a really key property. So radius, perpendicular bisector of a chord. Here's two examples how we're going to use that. All right, first one, all right, find x in 2 decimal places. Well, remember that a radius is here's the radius, that is a perpendicular bisector. So since this whole thing is 10, that means that piece right there is 5. So what I have here is I have a right triangle with this is 4, this is 5 now because it bisects, and this is my x. I use Pythagorean theorem, 4 squared plus 5 squared equals x squared. You're going to get 16 plus 25 equals x squared. That's 41 equals x squared, square root. X is going to end up being, I'm just going 1 decimal place, 6.4. Okay, so there again, there's that Pythagorean theorem based off the property. Now, number 6, really like this problem. Here's x, all right? It's a radius. Well, remember, I can draw a radius to any part of the circle and it will be equal. So what I want to do here is I want to take a radius and draw it here. And now you can see I've got that right triangle. This is 3, this is 4, and there's x is my radius. So Pythagorean theorem, 3 squared plus 4 squared equals x squared. I think most of you guys know this pattern. X is going to be 5, but if you weren't sure, it's going to be 9 plus 16 equals x squared, which is 25 equals x squared, square root, x is going to equal 5. So that's a key example of how you're going to use that radius to find, using Pythagorean theorem to find the value of the radius. Then the last one, pretty simple. Again, if chords are equidistant from the center, they're congruent, all right? So they're equidistant. That means that these chords are congruent. It goes the other way. If the chords are congruent, then they're equidistant to the center. So let's take one example, find x. Okay, they're equidistant from the center. That means that these are the same, okay? So not only is it from the center, that's a radius, so it bisects, so that means it's 6.5. So that means that this whole is congruent to all of this. So that's 6.5 plus 6.5, which equals 13. So there I have an example how you're going to use those three properties in circles to find the missing values.